Okay, welcome to another session in this series. In the previous session, we ended on question number 29. In this session, we move on to question number 30. The question says, if x to the base of 4, yani x base 4 is equal to 145 base 6, find x. So what this literally means is we have to convert this into base 4. So how do you do this? We first convert this into base 10, then we move it into base 4. So let's convert this to base 10. How do we do that? We number our digits 1, 2, 0, 1, 2. Okay, so that will give us 1 times 6 squared plus 4 times 6 power 1 plus 5 times 6, 0. That will give us what? 36 plus 24 plus 5, which gives us what? 65. So we need to convert this 65 base 10 into base what? 4. So how do you do that? We write our table. The remainder here, 65 here, and base 4. Okay, 4 can go into 64. 65 how many times? 16 times. Remainder 1. Okay, because 4 times 16 will give us 64. And 65 minus 64 is what? 1. Okay, cool. How many times does 4 go into 16? 4 times. Remainder what? 0. Okay, 4 remainder 0. How many times does 4 go into 4 ones? Okay, so we have ones, remainder what? 0. Okay, now how many times does 4 go into this one? 4 into this one, 0 times. Okay, 0, remainder 1. So that is our answer. That is our answer. 1001 base 4. Do we have it? Yes, which is D. Okay, cool. Let's move on to question number 31. It says, solve the equation this, leaving your answer in base 2. So there are two ways to actually solve this. The first way is to convert this into base 10. So you convert this to base 10, also base 10, also base 10. Okay, then when you do that, you can know what? Solve the question. Then after that, you convert into base 2. Or the second way to do that is to just work in base 2. Okay, so you expand in base 2 and then you group like terms and then you solve. Okay, so that's what I'm actually going to use. Okay, we expand and then we group like terms. The only thing we need to expand over here is this bracket because of this y minus 1. Okay, so now we have 100 100 base 2 y. Okay, minus, if we expand, you have 11 base 2 y plus 11 base 2 equals 1000. Sorry, I keep saying 11, right? Sorry, it's 1 base 2, and you have 1000 base 2. So now we can group like terms. Okay, we can group the y terms and then we group the non-y terms. Okay, so that means this would come to this side. Okay, so we have 100 y minus 11 base 2y is equal to 1000 base 2 minus 11 base 2. Okay, so as you can see over here, we can factor y out. Okay, so if you factor y out, we left with what? Base 2 minus base 2. Okay, also here we still have the same numbers. Okay, 1 base 2. So now we just need to what? Subtract this and also subtract this. Okay, so let's do that. Let's do this subtraction. That will be what? 100 minus 11 in base 2. Okay, so we borrow from here to here and then from here to here. Okay, and because we are working in base 2, whatever we borrow is 2, right? So when we borrow to here is 2, but we still need to borrow from here again. So what we borrow is also what? It's 1, but when it comes here, it is 2. So 2 minus 1 will give us what? 1. 1. And then when we got here, it was 2, right? But then we borrow from here. So what is left is what? 1. And this 1 minus 1 will give us what? 0. Okay? 0. And here, because we already borrowed from here already, so this place is 0. 0 minus nothing is what? 0. So for this portion, our answer is this. Okay? 0, 0, 1, which is the same as 1. Okay? Now let's do for the other portion, which is right here. What do we get? Let's try to subtract. 1, 0, 0, 0 minus 1, 1. Okay? So we borrow from all the way from here to this side. What do we have? 2 minus 1 is what? 1. Okay? So when it's in here, it was 2, right? But we also borrowed. So here is left with only 1. So 1 minus 1 will give us what? 0. Okay? 0. And here too, when we borrowed from here, right? So here was 2, but then we borrowed from here to this side and then to this side. So here is what? Left with 1. So 1 minus 0. 1 minus nothing will give us what? 1. And since we borrowed from here, what is remaining is what? 0. So here is just what? 0. So we can leave it like that. So this expression is what? So this is the result is this, and for this the result is 1. Okay, so what we have here is y 1 base 2 y is equal to 101 base 2. Okay, and then if we divide both sides by 1 base 2, 1 base 2, this cancels this, and then this one is still remains the same. Okay, so y is equal to 101 base 2. So that is our answer. Okay, which is B. Cool. All right, let's move on to question number 32. It says arrange the following in descending order of magnitude: 20 base 8, 20 base 8, 30 base 6, 23 base 7, and 19 base 12. Okay, so we convert everything to base 10 and then we compare. Okay, so first let's number our digits: 0, 1, 0, 1, 0, 1, 0, 1. Okay, so the first one is what? 1 times 8 power 1 plus 0 times 8 power 0. That will give us what? Oh no, this is 2, not 1. So this will give us 16. Okay. Now let's do the same thing for 30 base 10. So base 6, that will give us 3 times 6 exponent 1 plus 0 times 6 exponent 0. That will give us what? 18. And then we do the same thing for 2, 3. What do you have for 2, 3? You have 2 times 7 exponent 1 plus 3 times 7 exponent 0. That will give us what? 17. Okay? Okay? Now, finally, we have the base 12. That will give us 1 times 12 exponent 1 plus 9 times 12 exponent 0. And that will give us what? 12 plus 9. That will give us 21. So now we compare these 4 digits. These are in base 10, okay? These are in base 10. 10. 10. 10. And they say you should arrange in the what? Descending order, okay? So look for the largest. The largest is which one? 21, which represents what? 19. Sorry, 19 base 12. So we start with that. 19 base 12. Okay? Followed by what? 18. 18 represents what? 30 base 6. Okay, so we write that 30 base 6, comma. Then moving on, we go to 17, which represents what? 23 base 7. Okay, 23 base 7. And then finally, we have the last one, which is what? 16, which represents what? 20 base 8. 20 base 8. Descending order. Descending. Okay, so this is our answer. Do we have it right there? Yes, which is B. B is our answer. Okay, cool. Let's move on to question number 33. It says, if 4m4 base 5 is equal to 119 base 10, what is the value of m? So what we just need to do is convert these to base 5, then we can find our value of m. Okay, so how do you convert this to base 5? We draw our table, right? We draw our table, a simple table. We have 5, 119, we have our remainder. Okay, cool. How many times does 5 go into 119? 23 times. Okay, 23, and the remainder is what? 4, because 5 times 23 is what? 115. When you subtract 115 from 119, the remainder is 4. Okay, so let's do the same thing. 5 goes into 23 4 times, and the remainder is what? 3. Okay, because 5 times 4 is what? 20, and 23 minus 20 is what? 3. So that's the remainder. Okay, now 5 goes into 4 how many times? 0 times. Remainder is what? 4. So that is our answer. Okay, 4, 3, 4 in base 5. So now in our question, we are supposed to find what? M, which is the middle number of our answer, our solution, which is 3. So m is equal to what? 3. Okay, m is equal to 3. All right, I think we'll have to stop here for now. In the next session, move on to question number 34. Thank you so much for watching this session. See you again next time. Bye.